In this example, we are asked to find all zeros of the given polynomial x cubed minus 216. The way I'm going to work this out would be using the rational zeros theorem. So I notice that 216 is that lowercase p, and the leading coefficient is a 1, which is my q. So the possible rational zeros as you may already know, out of the form factors of p over q, which makes it plus or minus 1, plus or minus 6, and a few more. The factors of q, however, is just plus or minus 1. Mind you, I can keep going with listing all the factors of 216, or just quickly notice that 216 is a 6 cube, which means for sure the polynomial at 6 for an x value would render as 0. Correct? What does that make of 6? X equal to 6 is a 0 for the given polynomial. Alright? What else can be concluded from here? The polynomial at this stage can be written as x minus 6 times another factor. So the question is, how am I going to find that other factor? Yes, let's use the synthetic division. So I'm going to use 6 as a value for synthetic division, and p of x, let me remind myself, is x cubed minus 216, so that makes it 1. Coefficient of an x squared is a 0, right? Constant term is coming up at the end, but linear term, we can have a 0 as a placeholder for the coefficient, and finally there's negative 216. Alright, so let's begin synthetic division. So that gives me a 1. Multiply the 1 with the 6, and then add the terms inside. That makes it a 6, correct? 6 times 6 then is a 36 inside the box. Adding 0 and 36 gives us a 36, of course. And finally, the promising deal that 6 is indeed one of the zeros for the given polynomial is the fact that 36, when I multiply with a 6, is a 216, which gives you 0 at the end. So this is what I realized. P of x at this stage is an x minus 6 times the trinomial x squared plus 6x plus 36. The goal was to find all the zeros. We found one using the rational zeros theorem. So let's go ahead and use a quadratic formula on x squared plus 6x plus 36. So x squared plus 6x plus 36. Notice that a is 1, b is a 6, and c for that quadratic formula, the value should be set in, is a 36, correct? So x is equal to do we have a negative b plus or minus square root of b squared minus 4ac, or the discriminant just a 6 square minus 4 times a times SC all over 2a. That leads to negative 6 plus or minus. I'm going to plug this into the calculator. So 6 square minus 4 times 1 times 36 gave me a negative 108. Okay, so where does this take us? Negative 6 plus or minus. Let's try to break that square root of 108. Of course, the negative is going to lead to an I, so the other two zeros are imaginary. Okay, that's pretty evident right there. And square root of 108, mind you, the highest perfect square is a 36. Good. Times 36 times a 3. Yes, 36 times a 3. And I'm going to start writing that I at the end all over it too. Simplify. So negative 6 plus or minus 6 square root of 3 with an I at the end all over it too, mind you. Here we go. There are complex conjugates that are ending up to be zeros of the given polynomial. So that leads to negative 3 plus or minus 3 square root of 3 with an I. Okay. To sum it up, x equal to 6, negative 3 plus or minus 3 square root of 3i are all the zeros, mind you, real and complex. So one last thing left is to write this is in the factored form. So here we go, x minus 6, x minus 1 of the complex zeros. Some people have distributed the negative on the test. That's okay, as long as you know that it's x minus the 0, which is a factor. That's pretty good. And the third factor, I'm running out of space there, so which means I'm going to write it over here. X take away negative 3 minus 3 square root of 3i. That's what I was looking for. Writing it using the complex zeros also, instead of just leaving it right here. Okay, hope that helps.